So good afternoon. Thank you very much for joining us today. We promise not to keep you very long, so to shorten your journey between now and the drink session later. So today we are here to discuss, it's a mouthful of a topic, so it's Big SQL, the future of in-cluster analytics and enterprise adoption. Speaks really to two sides of the coin. Analytics, which has become so much more powerful over the last few years. Data, which has exploded in form, shape, in every way single possible. And on the other side, more and more enterprises that are buying into this concept of being data-driven. Was it a pipe dream? Not really. Enterprises have always wanted to invest more in data and tools, but the technology that we have at our disposal today has made it all possible. So to talk more about it, we have a lively panel here. I'm going to let you guys introduce yourself. Maybe tell us what you do, why you are here, and probably one interesting fact about yourself that we don't know.
All right. The mic's on. My name is DP. I am VP of Analytics at Yahoo. Been there for about a year and a half. And the problem that I was hired to solve was to enable data-driven decision-making across a 1,000-person department of Yahoo.com, all the Yahoo properties that you know of, and the mobile properties. Interesting fact about me, I love riding a motorcycle, and, and I come from California. So.
Hey everybody, I'm Nick Amabile, the co-founder of FullStack Analytics. Previously, I was at Jet.com and Etsy, and that's why I'm here, is the experiences at those companies implementing Big SQL. An interesting fact about me, I collect vinyl records. I grew up in Germany, and now I live in Brooklyn, so that's a little bit about me.
Okay, I'll go next. So I'm Surya Mukherjee. I cover information management for an analyst firm called Ovum. We are an independent analyst firm. And my job is really to sit between buyers and sellers of technology and try to match business problem to technology solutions. So I speak to both sides of the spectrum. And I don't know if this is interesting or not, but there are two topics in which I appear mildly knowledgeable. One is data and analytics. I can sort of talk to you about it. And the only other bit where I can appear a little bit intelligent is spicy food around the world.
Hi there, everybody. My name is Rex Gibson. I'm from New York. I work at a company called Knewton. Knewton is an adaptive learning platform. Basically, what that means is big publishers, small publishers give us data about their students and a map of their content, and we provide recommendations about what their students should learn next and analytics on how likely we think it is for a student to succeed in particular goals or targets. I head up the data warehousing effort there. So I have a few hats that I wear, from sort of product management from the data analytics side, also data engineering and traditional business intelligence. I serve a lot of different customers at Knewton. Before that, I was at the UN, and I've had a lot of different experiences building data warehouses from sort of old school enterprise and now in larger scale Big SQL.
I'm Lloyd Tabb. I'm the founder and CTO of Looker, which is a data sciences company. We make the product Looker, which basically enables companies to be data-driven. Before that, I was a CTO of a lot of different companies, notably LiveOps, which was a 30,000-person home-based call center, first crowdsourced company. I was also at chief architect on Netscape Navigator Gold, and I'm a long-time databases and languages guy. So, real geek. I code every day. And I ride a unicycle.
Right. So to get started, I think I met you guys last night, and we had a wonderful talk. So I think the first bit to get sorted out, the really intriguing bit is, what is this culture of being data-driven? I keep hearing about it. Almost every boardroom is talking about it today. But what does it really mean for you? Let's start with you, DP.
So what does it mean to be data-driven? To me, at Yahoo, there's my department is 1,000 people, and if we can make, if each of these people can make decisions, daily decisions using data, that is data-driven decision making. Be it, should I give more traffic to this partner? Should I acquire, what kind of content should we acquire? Or how is the site performing? How are the ads performing? Any of these. So,
fantastic.
Yeah, I definitely agree. I mean, I think the question is, how can we get data to the people actually making the decisions on the front lines? How can we get the domain experts interacting with data? And how can you get them asking and answering their own questions, essentially, with data? Because on the data team, you can't figure out all the questions that someone's going to ask, right? So the empowering those folks to make their own sort of decisions, answering their own questions, that's being data-driven, sort of in my mind.
Absolutely. In my experience, when I talk to a large number of enterprises all across the world, it's surprising and even shocking that the traditional relational databases, and on top of them, traditional BI tools, do not reach more than 4 to 5% of any organization and the intended audience, and that's being extremely generous with those numbers. So it is a real challenge. People have data, but they cannot put it into a form which is usable.
At Knewton, we have an interesting challenge and some advantages depending on which organization we're dealing with. We're heavily skewed towards engineering, so we have a culture that allows a lot of decision making. So for me, being data driven oftentimes just means like providing the least amount of friction to the information that's possible. But there's other parts of our institution that are much less sophisticated in terms of analysis. And on that side, I think one of the biggest things is gaining the trust of whoever you're working with inside of an organization, person by person, so that they feel comfortable and empowered to make those decisions and trust the data all the way to the point that they're looking at it. A lot of times we have big challenges in terms of looking at data, questioning, is it right? Is it this person's number right? Is it that person's number right? And that sort of makes some of the decisions about what is data-driven difficult to push further out into the institution. And oftentimes, so stakeholders will delegate out to an expert, and it's sort of like bridging that gap of trust and information all the way past the delegate is the big challenge.
Yeah, and I think one of the trends there is that you tended to hear about 10 years ago a lot about BICCs, right? So your center of competence, center of excellence, these were a group of experts sitting in isolation in their ivory towers, but they had no idea what the frontline salesperson needed. Instead, if you empower the user who's actually going to use the data for a business outcome, the results are drastically different. So Lloyd, what are your experiences about the other side, the enabling side of this discussion?
Well, it's the difference between vanity metrics and actual real metrics that drive operations is probably the biggest difference in data-driven companies. So a lot of companies think they're data-driven by measuring, say, daily active users. We have a lot of ride-sharing companies, for example, as one of our clients. And so you might say, oh, well, what's the number of people who are actually using the service? That's what a CEO is going to care about, and is that number growing? And that's a KPI, and it's more of a vanity metric, but you can't run your business by it. An example of a metric that you might care about if you're data-driven is the percentage of pickups that occurred within 3 minutes, for example. If you request something and 98% of them are occurring within 3 minutes, that's a real measure, an operational measure, and the ability to go, oh well, in this half hour we weren't meeting that. So being able to dive into the detail to figure out exactly where the problem occurred, and having anybody in the organization be able to do that, that's kind of what a data-driven organization looks like. It's being able to go, well, these are what's normal. Here's an outlier. What's causing the outlier, and being able to get to the bottom of it so that you can learn A, what's an advantage, or B, how to improve your services. So.
Brilliant. And simply put, that's a business problem that the business desperately wants to solve. But if you just peel back the covers a bit, then you start realizing that that's an incredibly difficult problem to solve when you're thinking about sort of what goes into making that one query come alive. So how difficult has it been for you guys to push that data-driven culture? Talk both about, let's say, the expectations of the business and how you had to work around that. And the second bit is obviously the technology bit. Did you have to work with SQL, NoSQL? So what was involved?
So Yahoo is an established company. So as I walked in there was like two top problems that I saw that was preventing the data-driven approach, or it was a bottleneck for it. One was there were too many tools, too many data tools for accessing data. So a person could have different interfaces and get the same number. And then when they do that, the second problem arises. Numbers were different. Right? So then the entire discussion shifts from making decisions to whose number is right, which tool is right, how far down does each tool go, and where does each tool stop. So this is kind of like a different game almost that ends up happening in enterprise organizations. So the solve was at a high level having a SQL interface to most of our data stores, because we use, we use a ton of data. It's a petabyte store. Hadoop, all the data is available in HDFS and Hadoop. And we use Hive to access all of it with a SQL-like interface. We use MySQL databases, Redshift, BigQuery, anything you can possibly think of. And enabling a central warehouse and a central interface, a constant UI interface across all of this was the start of the problem solving. There's another whole dimension to it, which is behavioral, which I'll probably get into later.
Yeah, I think that's absolutely right. I mean, to a large extent, the sort of technical problems have been solved with the advances in a lot of different sort of query engines, Hadoop, now with massive storage capacities. So it does become more of sort of an organizational or people challenge. And as DP is kind of mentioning, I think at Jet we sort of had a little bit of the opposite effect where everyone was working in SQL. SQL has such a low barrier to entry. A lot of folks come into an organization already knowing SQL or having used it in the past. And so it really does enable people to get access to the data really quickly. However, it creates like the snowflake effect where everyone's query is slightly different and everyone is sort of duplicating efforts in a sort of decentralized organization where there isn't strong communication necessarily across teams. You end up with this sort of duplication of effort. And so that's where a tool like Looker really comes into play, where we can provide this centralized interface. But not only that, but it's also a centralized store for business logic where we encode in the Looker models exactly what we want the user to see. And now instead of a user worrying about tables, joins, order bys, group bys, these sort of technical aspects, people can think in terms of, now I want this metric, or I want this sort of business domain object. I want to see sales by day. That's sort of a more natural language way to interact with data. And so that helps us sort of eliminate the challenge of, now we have 50 different numbers for the same exact metric, and sort of that speaks to what you were saying, Rex, about trust in the sense of, you have to enable that trust in an organization before people start actually using data. Yeah, and kind of what you're saying, if people are worried about is this number right, it shifts the conversation into a direction that you don't want it to go to. So.
Well, sorry.
No, go for it.
Okay. So starting at Knewton, I got there. I've been there 3 years, and they decided they wanted to start a data warehouse. And when I got there, there was basically an overwhelmed MySQL instance. Started checking into other technologies. There's lots of other data stores. We have a lot of different kinds of technology, from event stores to graph stores to more complicated and NoSQL kinds of engines that are very highly nested objects that help us to match things. And so first challenges were that there wasn't a lot of organization or information. We were just kind of counting users registered, and we couldn't even do active users when we started. And so doing some investigation, we went in, looked at a bunch of columnar stores, decided on Redshift. That's gotten us pretty far. At this point, we've now added visualization tools. We serve a lot of different people. And then our stack is now grown. We have had sort of Snowflake Hadoop, where we bring it up and do what we need to get it into an organization, drop it off in a lake, and then pick it up. And now we're moving to a point where I have to serve use cases that don't fit neatly into SQL just alone, but I need to use both of those kinds of operations. So we've got that challenge, so I serve that means, but the business side is fairly traditional, and so whatever land it's in, SQL is always going to be something that's sort of useful in order to kind of package up logic. It's an aggregate. Whatever you use, if you use a big SQL version, if you use Hadoop, you're counting, you're aggregating, you're performing simple functions, and the technology itself doesn't much matter. A nice thing about SQL is it's something that's relatively standard across a bunch of different dialects.
Yeah, I absolutely agree with that. I think from the time that McKinsey came up with that report, I believe a lot of us have read it, about how data science is going to become the thing, and we are going to face a huge shortage of professionals that know 3 disciplines together, all of that. But I mean, I have personally never agreed with that, because if you think about it, what McKinsey was proposing at that point was throw out all the existing skills that people know, throw out all the investments that you've made in the SQL side of the world, bring in something entirely new. But with any new technology, you have bridges. And at some point, you have to preserve investment in what you already know, especially from the skills front. So it's actually intuitive that SQL acts as the bridge to hold these worlds together. So,
one of the really interesting things about SQL is the ability to enrich data and to combine sources. So at first with the big MapReduce jobs about reducing and like taking event data and sessionizing it, for example. But SQL has gotten powerful enough in these big SQL engines that you can actually use SQL as a very simple way to actually combine sources. So take the ride sharing again. If you wanted to actually look at weather data for each of the rides so that you could figure out was the lateness caused by weather, for example, and you wanted to assign wind speed at the location of the pickup for each of the things, you could easily write this query in seconds or minutes in SQL. Just if you have the weather data available to you, it's a giant data set. Figuring out the location and then joining that all in SQL is actually a really easy thing to do, but is more complicated in writing MapReduce jobs. So you end up with a large group of people in your organization that can write SQL for the big SQL engines, but they can also write it for the small. DP, you were saying earlier today that all your data people speak SQL now, right?
Yeah, no, it protects investment, unlike people. But SQL is additive. It's not like it's taking anything away. We still use Hadoop. We still use Hive. We still have all the technologies, but that is primarily to process the data. And then accessing the data is where SQL kind of just ignites.
I quite liked your phrase about it being the Turing complete for data. I think I'm going to steal that.
Yeah, SQL is Turing complete for data. So there's a lot of bad implementations of SQL that are not quite Turing complete, but if you do SQL 92, it's pretty much Turing complete. You can do just about anything in it.
Right. So I think just shifting gears a little bit. So DP, again, starting with you, talk to us a little bit about how you started on the whole big data journey, where you met Looker along the way. So, I mean, how did that whole process start, and where are you today in terms of your tech stack implementation?
So at Yahoo, we use Looker as the front end for accessing all of our stores, so that for the business user or the user who wants to access data, they have to go to one UI and only learn one UI. And since all our stores support SQL, it's kind of makes it so simple for us to encourage this data behavior in people. From a stack perspective, it's if you hit Yahoo website, the browser triggers events. These events go into a store. Finally, it ends up in Hadoop. And then Hive, petabyte store, takes minutes to query. And then we have faster stores, which are pure SQL stores, column stores. And then we federate that using one UI across all, which is today for us Looker. And And this, it has changed the way that we actually operate, because now, with just one UI, I can innovate on the data storage completely independent from the UI, right? The UI is one, but I can kind of plug in Big SQL right there, and nobody needs to know even that there's Big SQL underneath it, right? So, and I'm really good at doing that part. Training the user and making them come to a certain place, that is the hardest problem in a company. And solving that once is worth it.
That's a fantastic insight. I think applying that layer of abstraction on top to sort of mask out the technology beneath, but that layer being something that you're comfortable working with because of SQL.
Yeah, it's 100% correct. I think we view Looker as like an API layer to the business, and essentially the thing that people think about is like sales or orders. Like those things will always be there, and we can change how we calculate those things. We can change how we what technologies we use underneath those to sort of materialize those. But it always ends up to the user end up being orders or sales or whatever. And it's at Etsy and Jet, the sort of story is fairly similar to what you guys are talking about, where I think big data for us starts with mostly clickstream data. That's sort of where you get really a pretty big explosion of users times events per visit times months and days and things. So that starts to explode your data set, and that's generally semi-structured data. And I think that's sort of what leads us to sort of the Hadoop world, where at Jet had an event source architecture. It didn't have any production relational databases. It was all sort of messages being passed across microservices as JSON. And so we wanted to basically keep that schema as close as possible to the original data source throughout the pipeline. And so that's where we come up with something like Hadoop, HDFS, where we can use something like Parquet to loosely schematize this data. Sort of the people who know this data then can recognize it as being familiar as the messages that are being passed in the system. And then SQL technologies like Presto, we use Presto at Jet, allow you to access complex data types just by using a fairly simple SQL language. So for us, that was really, really powerful to enable sort of interactive exploration of essentially raw data. And so people hadn't seen this data before, and people hadn't really been able to explore it in the way that we were able to allow them to explore it. And then again, Looker sort of sits on top of all that and abstracts away a lot of the sort of technical details of working with complex data, and again exposes this API layer to the business, saying here's your orders, here's your customers. Like those things are all familiar to business domain experts, but perhaps are sort of complex underneath the hood.
At Knewton, I started with a relatively small data set. When I walked in the door, there was 2 partners that we had, enterprise partners, and we had just shifted our business into sort of a more generic API. We'd done 2 big custom integrations with Pearson, a large education publisher, and we knew that we wanted to sort of make this a more enterprise API. So the fire hose started, we kind of had this evolution where it started out, we were just taking this data. We knew that we chose Redshift, and at the time, Redshift didn't ingest anything other than tabular data, so we had to get CSVs. So we started there, and then we evolved to JSON, and then we're now evolving to Avro. And there's this sort of evolution that happens as part of that world, and SQL has been the thing that keeps going step after step after step. So the same queries to identify what's a user that has a certain behavior, or sort of percentage correct or whatever, even though it's moved slightly between different languages, is something that has evolved with us and been fantastic. And the same thing, it gets passed to business users, it gets passed as a source for data scientists to use it. It's an interchangeable, connectable language. But we all have these problems where we start with like data, and we want to keep it raw as much as possible when we achieve it, and we want to get to the next preparation layer, and that usually requires some engineering or sort of sharp people to go. And then that next acquisition layer, depending on what your business organization's expertise is, there can be all sorts of different kinds of problems that you have to solve. And so choosing your technology, choosing your SQL languages, how you work through that becomes a very important part of the decision-making process. We needed something that was more sophisticated. We couldn't choose a SQL-like language that wasn't able to join tables because we didn't know exactly how we were going to push data into our sort of final store. And so for us, it was really important that whatever the SQL implementation was, that it actually was capable of joining disparate sources. We didn't have to do that eagerly. We could do it lazily. And that's, I think, a really important part in jumping to it. So we went from 100 million to we just passed 20 billion a couple weeks ago. And we're now opening in Asia. I've got, instead of one locality for data warehouse, I've got 3 localities. We're in Asia, we're in Europe, we're in the US. And all of that logic, again, because it's packaged SQL, it just picks up and puts down for every region and recycles over and over and over again.
Lloyd, I know this one is really not for you probably, but my question to you is, so, I mean, I'm hearing a lot of good things about Looker, but when you go out, what's the top 3 messages you think that resonate with your customers when you talk about Looker?
Basically, the message is essentially, if you're good at using your data, you're going to win in whatever industry you're in. And the more people in your organization that have access to it and are actively involved at looking at the business data, the more successful you're likely to be. I mean, it's the single message, right? So, yeah.
Yeah, I think what I'm also picking up is that there's a dramatic shortening of the time to innovation. So if you have a new use case you want to try out, given that you have this flexible architecture, you can just roll out and try it, and it doesn't cost you much. If you don't like it, just roll it back. Yeah. And no new skills. And that's a fantastic achievement for any organization that's on the edge of innovation. So I don't want to sort of not have a chance to invite questions from the audience. So we'll probably open up, unless you guys have some last comments.
Well, I'll probably have one last comment.
Sure, go for it.
The technology, in my mind, more than 50% of what I think about is not technology. Technology is only 50% of the game. The other 50% is how to behaviorally change people into looking at data. And that has its own complications, I'd say, almost in every organization. Techniques for that are varied too. So, no.
So at this point, I will open it up to questions. Go for it.
May I ask you a question? So you mentioned that you have 1,000 people working for you, if I understood correctly, 1,000 analysts?
No, the department has 1,000 people, product managers, engineers, then business operations folks. There's very few data analysts in this new model for us. The data analysts are required only for the insights into data, but for just querying the data and saying how many impressions, how many clicks, which customer, by date, all of that, the people can do it themselves.
But you have a really interesting model, DP. So he started with a big data team, got it to a small data team, and then started recruiting people back from the other teams to come work, learn data, and then go back. So it's, instead of having a centralized data team, he has a data intern program.
Correct.
Yeah, which is really wild. It's a really neat model. It's bring people to the data team so that they can learn how to see data and then bring that back to the rest of the organization. It's really fascinating what he's done.
Yeah, we do that too. I firmly believe that's the model. Like, start small. Get experts in each department. Almost all of us have that story of, like, you have a tool that works and can be flexible, and then department by department dub somebody to really understand and go the next level of understanding, and then make them responsible for enlightening the next part of the process. And we've actually built a formalized training program. It can be done at the drop of the hat. I collect 3 people who want to learn about that, and we teach the same thing over and over and over again. We give refreshers, and it's spaced over time to help with memory and learning, because you might not access the tool a lot. So, like, we've actually formally built an education program, and it gets more sophisticated over time.
Yeah, right. When you look at the department, it's 1,000 people for me, but the number of power users I need to ignite it's less than 10.
Yeah, I mean, I would just say that at Etsy we had a really strong centralized analyst team, and that worked really well for us. I don't think it would scale to a size of Yahoo, but I guess the point that I sort of would make is that I think laying the groundwork for a really strong data-driven culture, not to use that phrase again, but what I mean mostly is around the best practices around how to use data, how to, version control your SQL scripts, just stuff like that, that when you actually sort to become a practitioner sort of analytics, data science, whatever you want to call it, laying that groundwork so other folks then can sort of say, okay, there's a really strong culture of, version control and data lineage and data quality, and this is the domain knowledge that I need to pick up around analytics at a given company. Only then I think that's when you can start bringing other folks into the fold and be like, hey, we have this strong culture, here, come learn it, we'll teach you. I think that at Jet we had a really decentralized model, and that was what we were moving towards, is saying, hey, these are all the best practices so that everyone's on the same page, and that there's some communication and some sort of coordination of efforts. But I think then that's sort of how you scale that model, is then sort of embedding the domain experts, the marketing person that knows a lot about marketing. You need that person to really sort of be the bridge between data and marketing, for example.
One of my favorite mechanisms of teaching people in an organization data is to throw up, go into a conference room, throw up Looker on a television screen, and say, ask me anything. What do you want to know about the business? And then show people how they can pull the data out themselves. Right? It's not a thing. It's a thing that you can just do. It's like it's a learned skill, but it's not hard. But you've got to learn it, and so people are afraid of it to begin with. But then you can build advocates, so I can do that, and then they go do it. So
does Looker sit on top of a data lake? Is that kind
yeah, Looker sits on top of basically any SQL store. So we sit on top of BigQuery or Presto or Impala or
In order to answer any question about a business, supposedly all the business data sources have to be brought together first?
They not necessarily. There might be different ones in different sources, but Looker has a language component which actually describes how the data is related. So all the joins and all the calculations for things like taking a simple one would be grabbing a domain out of an email address. That might be a new dimension that's only exists in the model. Those kinds of things. But then you can actually look at stuff by domain or by. It's a simple modeling layer that's version controlled, that lets you explore, lets you actually give access to a very large group of people what they can get from SQL.
Question for DP, maybe Lloyd. Interesting what you said about federated data. I'm a customer and we have multiple data warehouses, but we don't have, we can't join in a federated way across those data warehouses using some technology, for example, like Apache Drill. I just wondered if you cross-join your data sources when you federate queries.
Oh yeah. So, like for us, data comes from Tumblr. Data comes from every ad engine that we have. Data comes from the mobile apps. Data comes from websites. And data comes from content acquisition that we do, because Yahoo is a content business. We get a lot of content from partners. So joining is the way we have solved, there's no silver bullet. The way we've solved the problem is Hadoop is our massive store. We dump everything in Hadoop. We don't try to join it in Hadoop. We kind of pull stuff into a relational or column store join capability warehouse, which is smaller. And to us, it's either SQL, MySQL, or one of these off-the-shelf ones like Redshift or BigQuery. And then use that to pump the data from here to there, and then use that place as the join place. And that works really well, where you get to keep your data the way you want to keep it in multiple warehouses, but then join it before you want to query it through a UI. And
so you're still physically moving the data?
Physically, yes, we are moving the data. What I found is there's a recency of querying. Like most people query the last 30 days or 60 days of data. And so high join capabilities are required there. And then for the rest, even if you have to go back to write a Hive query, which takes 6 minutes to run. It's not so bad. But it's almost like querying to me, it's a game that you're playing, and the pattern of querying is actually what you use to create your warehouse for the querying. So you don't need to solve every possible query problem, because you don't see the entire possibility of query problem. You see a small subset of what users are interested in seeing. And so that's where, again, I go back to, if you have one mechanism by which people come into query, you can analyze the query pattern and then tune your warehouse to that. When you have multiple tools, you can see the whole thing easier. So, I don't know if that answers your question. There was one here and then one there.
So when you look at your technology stack, where do you think, or how do you think about open source versus commercial tooling that you use? Do you have some preferred way? Like I hear a lot of sort of things at the base are like Hadoop and things like that, and on top of that, the sort of sexy layer is some commercial product. So what's your thinking behind the choice?
So for everybody, the question is, how do you decide which parts of the stack are open source and which parts are commercial? What's your thinking on that?
For me, it's always a demand question. So a visualization layer, we actually have a few of them, and for my data science community, demand is less for Looker and more for open source tools. So if you have engineers or people that are comfortable with that environment, you have you can provide tools like that. You get your problems where there's different sources of truth, but a data scientist generally can handle disagreements a little bit better about that than perhaps higher C-level people. But usually it comes to how much time is the person who needs that information willing to spend, and are you going to trade off in engineering or customization work of open source versus something off the shelf that meets your need and you get lots of choices. So that's sort of the axis that I look at it.
Yeah, I agree. I mean, I think it's sort of that cost-benefit analysis, but I think it's also about interoperability between things. So again, like as SQL being the language that most people speak, tools also need to interoperate with that somehow and provide that as an interface. With Hadoop, obviously, there's a lot of things that sort of interoperate with Hadoop. I hesitate to use the word ecosystem, but obviously there's a lot of things that plug into it, and it's been tested, right? But for something like, visualization layer, we've certainly built out our own dashboards and things like that, just using HTML and JavaScript, and that becomes very brittle and it's not flexible. And so again, the cost of maintaining that and doing custom work every time someone needs some highly changing, edit to a metric, that's where we don't want to necessarily spend the time to maintain that, and that's where something like Looker allows us to really quickly iterate on the query layer, as opposed to, like, again, we're not really iterating a whole ton on the data lake layer. That's just baked, and then the query time is where all the sort of analytics happen. And like Rex, the key is to provide a few different interfaces for that. Obviously, a lot of people will just want to get their reports and call it a day. Then the data scientists want to have a notebook where they can use Python, or some of the folks want to use Scala or Spark or something like that. So you provide sort of a multitude of interfaces. But again, those are for people who want to iterate more on the query layer.
Sorry, I think we are out of time, but thank you very much for participating. If you do have questions, grab these guys as they're going out. Don't let them go. And have a happy rest of the event. Thank you very much.